Welcome to the video for our demo paper titled Interactive Evaluation of Recommender Systems with Sniper, an episode mining approach. In this video, we will present an overview of our system. We will start with preparation steps, such as loading in the data, creating workspaces and worksheets. Then, we will move on to the core functionality of Sniper. After providing a basic overview of the UI and the interaction paradigm, we will move on to our use case, analyzing recommender systems data. We provide two options for uploading your data into the system, either via file upload or a connection to a SQL database. For the first option, you need to provide a name and an optional description. The latter option can be configured on this screen. For this demonstration, we will work with a subset of the Outbrain dataset, containing data from a single publisher. This dataset contains log behavior of user clicks on articles as well as shown recommendations. Before taking a look at the data, we must create a scheme for the uploaded data table. The scheme is a description of what the data looks like. It contains basic information such as the name, an optional description, and the type of the data that it holds. In this case, we will set the publisher ID as the name and leave the data type untouched. A preview of the first 10 rows of the data is shown on the bottom of this screen. It can be used to select or deselect certain attributes. As page views, impressions, and clicks are represented by item identifiers, we will set their types to categoric. We are now ready to save our newly created scheme. After saving the scheme, two buttons appear. View Scheme provides a read-only version of the scheme's attributes. View Workspaces will show the available workspaces. Let's do that. Like a Microsoft Excel workbook, workspaces can contain multiple worksheets. We have already created a new workspace for the purpose of this demonstration. As can be seen, the workspace does not contain any worksheets yet. If we load it in, we will be directed to the worksheet creation page. Now we will provide a name for the worksheet and an optional description. Let's name it after the publisher. We link the worksheet to a given data table and a given scheme. This will give us some options such as discretization and the number of bins used. These are not applicable for our use case. However, we will set the data type to a sequential data table, as we are interested in the temporal aspect of our data. The ID attribute sets the column used to group data records and should be categoric. The distance attribute specifies the attribute to order data records on and should be numeric or a date. We generate a single sequence with large gaps between users as input for our episode mining algorithm. Now that our worksheet has been created, we can focus on Sniper's core functionality. The top drop-down will show all available worksheets. The minus removes the current one, and the plus is used to create a new one. The lower left-hand side of the screen is called the work doc. This will contain all patterns, either manually constructed or automatically mined, along with their interestingness measures. The toolbar has buttons to change options, save the worksheet, enable measures and visualizations, and so on. The lower right-hand side contains the source doc, which contains the basic building blocks to create patterns with. By default, these are sorted by support, but this can be changed to rule confidence. The upper right-hand side is the information doc, containing high-level information about the data in this worksheet. Starting to create patterns is as easy as dragging basic building blocks from the source doc to the work doc. If we drop the block, we will create a single episode pattern. We can select multiple elements one by one and drag them onto the work doc to extend the pattern. If you drop it before the episode, we will create a rule with a new element as the antecedent. On the episode, we'll extend the current episode, and after, we'll create a rule with a new element as a consequent. We can also add selected blocks as singletons to create multiple patterns at a time. Single elements can be removed by clicking on the X that appears after hovering over the element. Entire patterns can be dropped via the buttons on the right-hand side. The elements from an episode can be clicked, resulting in additional buttons used to link one element to another element and create sequential preference relations. Different interestingness measures can be enabled and calculated on the fly to evaluate the existing patterns on the workdoc. Here, support indicates how often the pattern occurs in absolute numbers. Rule confidence is a percentage of how often the rule is found to be true. Measures that are not applicable will show as not a number values. We added some general tools to analyze this type of data. We will show how to use them in this setting. First, we clear the worksheet. Then we select the simple episode rule minor from the minor menu. Now we can set some basic parameters. Let's say we want to get rules that occur at least 200 times and rules that have a confidence of at least 0.2. We can also filter on the type of items that occur on the left and the right hand side of the rule. Let's say we want impressions on the left hand side and clicks on the right hand side. If we now click Run Minor, all patterns that adhere to those parameters will be generated and shown in the workdoc. These patterns represent how often items are recommended, and when they are recommended, how often they are clicked. This absolute number is shown as a support. The confidence of the shown rules can be interpreted as a click-through rate for every given item. Now, we can sort the generated patterns by the enabled measures. For example, descending or ascending support. If we sort the rules by descending confidence, we get the items with the highest CTR on top. The item on row 4, for example, has a CTR of 50% and has been clicked more than 3,000 times. We can now scroll through all the patterns to find the most interesting ones. Now we will focus on one specific pattern. We will copy it to the clipboard, clear the workdoc, and paste the pattern again. Now we will select a pattern and activate a pattern post-processing algorithm to extend the current episode with single elements from a given column. We set the type to impression, as we want to add impressions to the antecedent and the consequent of the rule. After a few seconds, all the extended patterns that have a support of at least 1 will be shown in the workdoc. The confidence of these rules represents how the CTR of the given item fluctuates when it is recommended in combination with other items. However, when scrolling through the generated patterns, we see that many have a support below 10. As a consequence, it is hard to draw conclusions from them. We will now remove our first simple CTR rule from the workdoc. Remember that the CTR of the item we're examining is roughly 20% on average. Now, we use the measure-based pattern filter to remove all patterns with a support lower than 10. Now we can analyze the CTR a bit better. The general rule had a CTR of 20%, while the others fluctuate quite a bit. Clicking on the little chart next to the measure will open a window showing additional information for that measure and all patterns in the worksheet. This view gives a rough idea of the distribution of the given item's CTR when it is recommended in combination with all the other items. Although some outliers are clearly present, it roughly follows a bell-shaped distribution with a mean of 0.21 and a standard deviation of 0.07. We can now see if any patterns exist in the worksheet that have an unexpected CTR by running the measure-based outlier pattern filter post-processing algorithm. This uses the default z-score that is used to identify outliers for the rule confidence. Here we see that two interesting patterns remain. Let's focus on the first one. We see here that when these two items are recommended together, the CTR of the first item rises quite a bit. Now, it might be interesting to look at the average CTR of the second item. We look for the click event for this item in the source doc. Then, we drag it onto the existing episode to generate the rule. We can see that this item has been recommended and subsequently clicked 52 times with an average CTR of around 15%. Now, let's have a look whether recommending the first and second item together has an influence on the CTR of the second item. We see that they are recommended together 24 times. The CTR of the second item, however, drops to 0% when it is shown in combination with the first item. These types of findings warrant further analysis of the items in question, which could certainly be useful when information about their content, for example, is also known. Finally, we can also have a look at the specific occurrences of the first pattern in the data. When we click on the magnifying glass next to the rule, an overlay is shown with this information. Now we have an overview of all windows containing the selected pattern, grouped into user sessions. This specific user session starts with a page view, followed by 6 recommendations and a click on one of them. Then we have another page view, another 6 impressions, and another click. Note that the final impression and click are the item that we're most interested in. When we're done analyzing the patterns, we can clear the worksheet once again. This concludes our demonstration. Although we mainly focused on simple rules and patterns for brevity, our system facilitates the exploratory analysis of more complex situations as well. Thank you for your attention.